What if I told you that 2,000 years ago, people built faster than they do today? Without a drop of gasoline, a single computer, or an electric motor. Modern megacities are suffocating under endless construction projects, where building a single interchange takes years, while ancient engineers created gigantic complexes in a matter of months. We are used to thinking of ourselves as the pinnacle of progress. But the Roman legion was able to build a fortified city from scratch before the sun set. Their secret lies not in lost alien technologies or magic, but in a system that turned construction into a flawless conveyor belt of death and creation. Watch the video to the end to find out how the Romans turned the shovel into a weapon as formidable as the sword, and why their concrete lasts for millennia, while our houses crumble after half a century. What if I told you that everything you believed about the Roman army is not true? We are used to seeing legionnaires exclusively as warriors clad in armor and marching to the beat of drums toward the enemy. However, the reality is that for most of their service, these men did not wield a gladius or a pilum, but a pickaxe, a shovel, and an axe. The Roman legion was not just a military machine, but a highly efficient construction corporation with a staff of 5,000 employees. Each recruit underwent a rigorous selection process, which assessed not only his physical strength, but also his ability to perform heavy, monotonous labor. Versatility was the main principle of this organization, where each soldier was simultaneously a mason, a carpenter, and a digger. In addition to provisions and personal belongings, their backpacks always contained a full set of entrenching tools. This allowed the command to launch large-scale construction at any moment, without waiting for the arrival of civilian specialists or supply trains with equipment. 5,000 men could simultaneously begin digging a trench, cutting down trees and hewing stones, creating infrastructure at an alarming rate. No modern construction company can afford to maintain such a staff of versatile workers on a single site. Discipline on the construction site was as ironclad as on the battlefield, because the life of the entire unit depended on the speed of the work. Officers, centurions, and optios acted as foremen, strictly controlling each stage of the construction of the fortifications. Poor masonry or an insufficiently deep moat were punished as severely as sleeping on duty. This system eliminated the delays, smoke breaks, and endless meetings that plague modern projects. Here, everyone knew their place, their task, and the quota they had to meet before sunset. The legionnaires' tools were simple but perfected over centuries of use in a wide variety of climatic conditions. The delabra, a pickaxe axe, became a symbol of Roman engineering genius, allowing them to cut through tree roots in stony ground. They did not wait for spare parts for complex equipment, because a broken handle could be replaced in 5 minutes in the nearest grove. The simplicity of the tools was compensated for by their number and the muscle power of thousands of people working as a single organism. It was a living machine that knew no fatigue and required no fuel. Engineering training began on the first day of service and continued until the veterans' retirement. Recruits were taught not only how to chop and cut, but also how to mix mortar correctly, lay turf, and tie knots. Knowledge was passed on from older comrades to younger ones directly in the course of work, without interruption from production. There was a clear specialization in the Legion. Some units worked better with wood, others specialized in earthworks. But if necessary, any cohort could be replaced by another, ensuring the continuity of the process. The Legion did not depend on external contractors. It produced everything necessary for construction right on site. It included blacksmiths, potters, carpenters, and even architects capable of designing the most complex structures in the field. Field workshops were set up in a matter of hours, providing the construction site with nails, staples, and tools. It was complete autonomy, which modern builders can only dream of. The Romans carried civilization with them in their wagons and in their heads. The speed of the legionnaires' work amazed their contemporaries and Rome's enemies, who often surrendered without a fight at the sight of the growing walls. There are known cases when siege towers and ramparts were built overnight, completely changing the landscape of the battle. This psychological pressure was part of the military doctrine. to show the enemy that resistance was futile in the face of such organized power. The Romans won not only with the sword, but also with their ability to change the world around them with incredible speed. An engineering shovel was often more effective than a siege ram. The organization of labor allowed work to continue around the clock, replacing tired shifts with fresh forces. While some slept, others continued to deepen the moats and erect palisades by torchlight. This conveyor belt method left the enemy no time to react or regroup. The continuity of the process ensured that by morning the camp had been transformed into an impregnable fortress. Time was the main resource, and the Romans knew how to save it better than anyone else. Large-scale projects, such as roads or aqueducts, were built by several legions working towards each other. Coordinating the actions of such huge masses of people required the highest level of management and planning. Senior officers possessed logistic skills that would be the envy of modern multinational corporation executives. They managed the flow of people and materials with clockwork precision. Errors in calculations could cost careers or even lives, so they were virtually non-existent. This mobile construction corporation left behind traces that are still visible even after 2,000 years. The roads, bridges, and fortress foundations built by these people have outlived empires and civilizations. Their labor was invested in every stone, every meter of paved road laid through wild forests. The legion proved that organized human labor can overcome any obstacle nature throws at it. I'm really curious to hear your thoughts. What do you think about such strict labor discipline? Is it slavery or the height of efficiency? Let me know in the comments. Are you ready to learn the truth about the secret that changed the world of construction forever? The Romans were the first to realize that uniqueness and creativity in mass construction are the enemies of speed and quality. They introduced strict standardization, turning the construction of military camps and cities into a construction set assembled according to a pre-approved plan. Every fort, from the hot sands of Syria to the misty hills of Britain, was built according to the same standard design. This eliminated the need to reinvent the layout each time and waste precious time on disputes. Every legionnaire had a clear plan of action in his head, hammered in by years of training and practice. When arriving at a new location, the soldiers did not wait for instructions from the architect on where to pitch the commander's tents or where to dig latrines. They simply followed standard procedure, knowing that the centurion's tent was always in a certain row and the granary was in the center. This predictability allowed any soldier transferred from another unit to instantly find his bearings in the new camp. It was a system that worked on a reflex level. Standard solutions applied not only to the layout, but also to the dimensions of all structural elements. The moat always had a certain depth and profile, and the rampart had a standard height and angle of inclination. The width of the gates, the height of the towers, the thickness of the walls. Everything was specified in military regulations and instructions. This made it possible to prepare materials in advance, knowing that a log of a certain length would be exactly right for building a gate. No on-site adjustments, no production waste, and no unnecessary sawing. The modularity of the structures was another ingenious invention of Roman engineers, ahead of its time. They used standard sizes for bricks, beams, and tiles, which allowed them to be mass-produced in different parts of the empire. Quarries and brick factories worked according to uniform patterns, providing construction sites with standardized parts. If a beam broke during construction, it could be easily replaced with another one taken from stock. It resembled modern industrial production, transferred to antiquity. Standardization greatly simplified logistics and supply for a huge army in enemy territory. Quartermasters knew exactly how many nails, boards, and tools were needed to build a camp for a certain number of people. There was no need to make complex calculations or guess whether there would be enough materials to complete the work. Supply requests were simple and straightforward, which reduced the likelihood of errors and theft. The efficiency of the rear directly affected the speed of the front's advance. Even temporary camps, which were built for just one night, were erected in compliance with all standards and rules. The Romans never cut corners, believing that security could not be temporary or partial. Every night, the army slept behind solid walls, in the usual order and safety. In the morning, the camp was dismantled or destroyed so that exactly the same one could be built on the next march. This maniacal repetitiveness created a sense of stability and order. Textbooks and construction manuals were reference books for the legion's officers. The experience of generations of engineers was systematized and recorded to prevent the loss of knowledge. Young tribunes studied diagrams and drawings before giving their first orders on a construction site. The mistakes of their predecessors were analyzed and taken into account so as not to repeat them in the future. The Roman army was a learning system that was constantly improving its standards. The uniformity of architecture also had an important psychological aspect for the conquered peoples. Wherever the legionnaires set foot, identical buildings, roads, and aqueducts appeared, symbolizing the power of Rome. This showed that the empire was not just a conquest of territory, but the arrival of a new, orderly way of life. The standard appearance of a Roman city was a brand recognizable in every corner of the ancient world. Barbarians saw in this geometry a force that could not be resisted. Thanks to standardization, the Romans could move engineering units from one end of the empire to the other without losing efficiency. A builder who erected an aqueduct in Spain could continue working on a bridge over the Danube without retraining. The language of drawings and diagrams was universal and understandable to everyone, regardless of origin. This created a unified engineering space that united vast territories. Globalization began precisely with Roman construction standards. In the next chapter, we will reveal the secret mechanisms that allowed multi-ton loads to be lifted using the strength of just a few people. Guess how long it took to create this? Roman engineers understood perfectly well that muscle power alone, even multiplied by thousands of hands, was not enough to lift giant stone blocks. They did not have powerful diesel cranes, but they did have physics, which they made work for them with maximum efficiency. Mechanisms that seemed simple at first glance turned unliftable weights into feathers, allowing them to build colossal structures. The secret lay in a system of blocks, levers, and gear ratios that the Romans perfected. The main hero of the Roman construction site was the pulley block, a system of several movable and fixed blocks strung on a single axis. The more blocks there were in the system, the less effort was required to lift the load, although more rope had to be pulled. An ordinary soldier could lift with one hand a weight that 5 strong men could not move. It was true mechanical magic, turning weakness into strength. Mathematical calculation defeated the raw mass of stone. The crowning achievement of engineering at that time was a huge crane with a treadmill wheel, inside which people walked. This device worked on the principle of a squirrel wheel, only instead of rodents, specially trained workers walked inside. Their weight created enormous torque, which was transmitted to the lifting rope through a system of shafts. 2 people inside the wheel could lift several tons of stone to a height without visible effort. It was a brilliant use of gravity against gravity itself. The precision of positioning loads using such cranes was simply phenomenal for that era. Experienced operators could lower a multi-ton column onto a pedestal with an accuracy of a few millimeters. Commands were given by gestures or whistles, and the coordinated work of the team resembled the actions of a ship's crew. No jerks, no dangerous swings, just a smooth, controlled upward movement. The stone obediently settled into its designated slot. Equally ingenious devices and methods were used to move heavy loads horizontally. Stone blocks often had special protrusions or holes for grips, which were called wolf's mouths. Metal clamps clamped the stone under its own weight, ensuring a secure hold. As soon as the block was put in place, the clamp loosened and was easily removed, saving workers time. Every detail of the process was designed to speed up installation. Winches and capstans allowed loads to be pulled up inclined planes using the strength of oxen or slaves. The ropes were made from the best quality hemp and were regularly checked for wear to avoid accidents. Lubricating the axles with animal fat reduced friction and increased the efficiency of the mechanisms. The Romans knew that taking care of equipment was the key to its long and trouble-free operation. A broken crane meant a halt to construction, which no one could allow. The methods used to install the giant obelisks brought from Egypt to Rome are particularly impressive. Special scaffolding was built to lift them, and hundreds of winches were used, working synchronously on command. Thousands of people pulled ropes at a single signal from a trumpet, slowly, centimeter by centimeter, raising the monument to a vertical position. These were extremely complex engineering operations that did not tolerate a single mistake. Load calculations were made in advance, with a huge margin of safety. Roman mechanisms were collapsible and mobile, so they could be transported in the legion's convoy and assembled on site. This made it possible to use heavy construction equipment even in the most remote and wild corners of the empire. It took several hours to assemble the crane, after which it immediately went to work, speeding up construction many times over. Mobility was a key factor in the success of Roman expansion. Technology followed the legions closely. Engineers constantly experimented with materials, replacing wooden parts with metal ones in the most heavily loaded components. Bronze bushings and iron axles significantly extended the service life of the mechanisms. The wood was impregnated with special compounds to protect it from rotting and drying out under the scorching sun. Maintenance was carried out regularly because the lives of people below depended on the crane being in good working order. The culture of production was at the highest level. These simple but effective machines allowed Rome to build the world with stone in a time frame that seems fantastic. Without cranes and winches, the Colosseum and the Pantheon would have remained only beautiful drawings on papyrus. Mechanics gave man power over matter that he did not have before. Like this if you are also impressed by how skyscrapers can be built without electricity, and be sure to subscribe to the channel so you don't miss any new videos. What if everything you've been taught about building materials is outdated? We're used to thinking that concrete is an invention of the modern industrial era, of gray panel buildings and skyscrapers. But the truth is that the Romans used this material on an industrial scale 2,000 years before us, and their concrete was better. The secret to their incredible speed of construction lay in opus cementitium, Roman concrete, which allowed them to pour huge volumes of walls and arches instead of carving each stone by hand. It was a real revolution that freed architecture from the limitations of masonry. The main ingredient of this miracle material was volcanic ash, pozzolan, which was mined in the vicinity of Vesuvius and the Phlegraean fields. When reacted with lime and water, this ash formed incredibly strong crystalline bonds that only became stronger over time. Unlike modern cement, which begins to deteriorate after a few decades, Roman concrete could stand for centuries, turning into a monolithic rock. Time worked for it, not against it. The chemistry of antiquity surpassed the chemistry of modernity. A unique property of Roman concrete was its ability to harden directly in water, which made it indispensable for the construction of bridges and ports. Engineers lowered wooden molds to the bottom of a river or sea and poured in a mixture that hardened even without access to air. This made it possible to create foundations where it had previously been considered impossible. The speed of bridge construction increased tenfold. Rivers ceased to be an obstacle for Roman roads. The technology of pouring walls using formwork turned construction into a fast and technologically advanced process. Instead of fitting each stone to each other, workers built two thin brick walls and filled the space between them with concrete mixed with stones and gravel. This required far fewer skilled masons and allowed the use of cheap, unskilled labor. The walls grew like yeast, layer by layer. The savings in time and money were enormous. Roman concrete was not only strong, but also surprisingly malleable, allowing for the creation of any shape, from domes to arches. The Pantheon in Rome, with its giant unsupported dome, is a monument to the possibilities of this material, which still stands today. Engineers changed the composition of the mixture according to the height of the dome, adding light pumice at the top to reduce weight. It was a precise engineering calculation embodied in liquid stone. Freedom of form ushered in a new era in architecture. The use of local aggregates, stones, broken bricks, pebbles, made concrete production cheap and accessible anywhere in the empire. There was no need to transport expensive marble thousands of kilometers. All that was needed was pozzolan and lime. Local materials were literally lying at their feet, waiting to be turned into part of the great empire. Logistics were simplified and construction speeds accelerated. The empire was built on what it stood on. The waterproofness of Roman concrete made it possible to build giant water tanks, aqueducts, and thermal baths without fear of leaks. Special additives and careful tamping of the mixture made the walls of the reservoirs completely watertight. Water, the main resource of life, was reliably stored in stone vessels created by the hands of engineers. Sanitation and hygiene in Roman cities relied on the reliability of concrete structures. Without concrete, there would be no Roman baths. The Romans understood the importance of preparing the mixture correctly, so special supervisors monitored the process. The proportions of the components were strictly observed, and the mixture was stirred until a homogeneous mass was obtained. Poor quality mixing could lead to the collapse of a building, and those responsible were held strictly accountable. Quality control was an integral part of the technological process. Sloppy work on a construction site was equated with sabotage. The seismic resistance of concrete monoliths saved many Roman monuments from destruction during earthquakes. While stone blocks shifted and fell, the concrete structure worked as a single unit, withstanding enormous loads. The flexibility and strength of the material dampened underground tremors. Many buildings survived where nature destroyed everything else. Engineers built for centuries, and they succeeded. Concrete allowed Rome to scale its greatness, replicating huge structures throughout the known world. It was the material of the empire, solid, durable, and versatile, like Roman power itself. The secret of its composition was lost in the Dark Ages, and it took humanity 1,000 years to reinvent what the Romans used every day. In the next chapter, you will learn how the Romans coped with terrible weather and swampy soils when building their legendary roads. The second most important factor in the speed of construction was the roads themselves, which allowed materials and people to be transported anywhere with incredible speed. A Roman road was not just a beaten path, but a complex engineering structure that went a meter or more into the ground. Construction began with the complete removal of soft soil down to solid rock or a dense layer of clay. This ensured that the road would not sink under the weight of heavy carts and marching legions. The thoroughness of this approach eliminated the need for constant repairs. The layered cake of the roadbed consisted of 4 different layers, each of which performed its own function. The bottom layer of large stones, statumen, served as a foundation and drainage, diverting water from the base. This was followed by a layer of crushed stone with lime, rudis, which gave the structure elasticity and monolithicity. The third layer, nucleus of fine gravel and sand, leveled the surface for the final coating. This structure acted as a shock absorber, distributing the load. The top layer, summum dorsum, was laid out of large, tightly fitted stone slabs with a convex shape. The center of the road was always higher than the edges, which caused rainwater to instantly drain into drainage ditches on the sides. Roman roads remained dry and passable in any downpour, while ordinary dirt roads turned into impassable mud. The army could move at the same speed at any time of the year. Weather ceased to be a factor, slowing down the empire. Surveyors used a special tool called a gramma to lay out routes with perfect straightness. Roman roads ignored the terrain, seeking to connect 2 points by the shortest route, cutting through hills and filling in ravines. The straight line was a symbol of Rome's will to subjugate nature rather than adapt to it. This reduced distances and travel time, making the world more compact. Travelers always knew that the road beyond the horizon was just as straight. In swampy areas, engineers used complex soil reinforcement techniques using wooden piles and causeways. They built entire floating foundations that allowed the road to pass through quagmires where animals drowned. The ability to build on unstable ground was the pinnacle of Roman engineering. There was no terrain that the legion could not make passable. The swamps retreated before the onslaught of stone and wood. Milestones were placed along the roads, indicating the distance to the nearest cities and to Rome itself. It was the world's first navigation system, allowing for accurate planning of travel time and troop movement speed. The information infrastructure was as important as the physical one. A traveler never felt lost on a Roman road. Knowledge is also speed. Inns and horse-changing stations were located at regular intervals, providing courier services with everything they needed. Fresh horses allowed messengers to cover hundreds of kilometers a day, delivering orders and news with lightning speed. It was the ancient internet, powered by oats and endurance. Governing an empire required instantaneous responses, and its roads provided them. Communication tied the provinces together into a single entity. The width of the roads was standardized so that 2 chariots or carts could pass each other freely. This prevented traffic jams and congestion, ensuring high throughput capacity for the transport artery. Trade caravans and military convoys moved in a stream without interfering with each other. The economy and war shared the same road, reinforcing each other. The well-thought-out dimensions spoke of strategic planning. Roman roads often outlived the empire itself, serving people for centuries after the fall of Rome. The quality of construction was such that many modern highways in Europe are built directly on top of ancient roads. The foundation laid by legionnaires 2,000 years ago still supports asphalt and cars. This is the best proof of the effectiveness of the Roman school of construction. They built for eternity. The network of roads that crisscrossed the Mediterranean became the skeleton on which the entire ancient civilization was based. Without these stone arteries, Rome would never have been able to become a world power controlling vast territories. Speed of movement was the main strategic advantage of the legions. The road was a weapon aimed at the heart of barbarian lands. Are you ready for the shocking truth about how water conquered gravity? Roman aqueducts are not just beautiful arches on postcards. They are a triumph of precise calculation over the chaos of nature. To deliver clean mountain water to crowded cities, engineers had to maintain a constant, barely noticeable slope over tens of kilometers. A calculation error of just a few centimeters could cause the water to stagnate, or conversely, turn into a destructive torrent. This required mathematical precision bordering on artistry. Most of the aqueduct actually ran underground, in tunnels and pipes, hidden from view. This protected the water from contamination, evaporation, and poisoning by enemies during wartime. The Romans were masters of underground construction, drilling through rocks and hills from both sides simultaneously, meeting in the center with minimal error. Underground channels required enormous effort, but guaranteed the safety of the water supply. An invisible river flowed in the darkness to give life to the city. The famous arch bridges were built only where it was necessary to cross a valley or ravine, maintaining the precious level of elevation. The arches saved material and created open work, but incredibly strong structures capable of withstanding the weight of thousands of tons of water. Each arch rested on the previous one, creating a chain of forces that kept the bridge in balance. Aesthetics here were a byproduct of perfect engineering function. Beauty was born out of necessity. Giant scaffolding, which took up entire forests, was used to build high aqueducts such as the Pont du Gard. Workers lifted stones to dizzying heights, working on narrow platforms without any safety equipment. The builders' courage matched the genius of the architects. Each stone was cut on the ground and lifted up to take its unique place in the masonry. It was a giant three-dimensional puzzle. Waterproof plaster inside the canal, consisting of lime, oil, and crushed ceramics, prevented leaks. The walls of the canal were smooth as glass to minimize friction and prevent algae growth. Water purity was a priority, and engineers created a system that maintained its own hygiene. Regular manholes allowed the canal to be cleaned without stopping the flow completely. Maintenance was built into the design. The Romans used the principle of communicating vessels to create culverts, systems of pipes that allowed water to descend into a valley and rise on the other side under its own pressure. This made it possible to cross deep gorges without building cyclopean bridges. Lead or ceramic pipes withstood enormous pressure, proving the skill of ancient plumbers. The physics of liquids were studied and put to use. A system of sedimentation tanks and filters along the water's path cleaned it of sand and debris before it reached the city. The water reached the consumer clear and cool, having undergone a complex purification process. The Romans were obsessed with water quality, understanding the link between dirty water and disease, even though they did not know about microbes. Engineering solutions replaced medical knowledge. The health of the nation flowed through these stone channels. Aqueducts were built with enormous reserves of strength, designed to last for centuries of use and possible cataclysms. Many of them continued to operate in the Middle Ages, supplying cities with water even after the fall of the empire that built them. The margin of safety was such that only time, not negligence, could destroy these structures. The Romans did not build for a warranty period, but for eternity. The arrival of water in the city was a celebration of engineering. Fountains, baths, and public toilets operated around the clock. Water washed the dirt from the streets into a grandiose sewer system, the Cloaca Maxima, making Rome the cleanest metropolis of antiquity. The infrastructure provided a standard of living that was unattainable for most European cities until the 19th century. Comfort was a product of engineering. Aqueducts became a symbol of man's victory over drought and distance. bringing life to arid places. They turned deserts into gardens and allowed cities to grow to incredible sizes. Water was the lifeblood of the empire, and aqueducts were its veins. In the next chapter, you will learn how the Romans built a wall across an entire island to protect themselves from the barbarians. On the northern border of the empire, in Britain, Emperor Hadrian ordered the construction of a wall that would divide the island in half. This structure, known as Hadrian's Wall, became one of the most ambitious construction projects in history. The wall stretched 117 kilometers from sea to sea, crossing hills, rivers, and cliffs. It was not just a pile of stones, but a complex fortification system that included moats, ramparts, forts, and watchtowers. The scale of the work is impressive even today. The construction was carried out by 3 legions, which divided the workfront into sections. Each centuria was assigned a section of the wall and was required to build it as quickly as possible. The names of the units were often carved into the stones to immortalize their work and mark their area of responsibility. The competitive spirit between the units spurred the pace of construction. Everyone wanted to prove that their section was the best. The logistics of delivering materials to a wild and hostile terrain was a nightmare. But the Romans coped brilliantly. Where there was no stone, the wall was built from turf, laid using a special technique that made the rampart as strong as concrete. Where there was limestone, stone walls were erected and bonded with mortar. Flexibility in the choice of materials meant that construction did not have to be stopped for a single day. Engineers used what the terrain had to offer. Along the wall, every Roman mile, there were fortified forts, mile cases, where the garrison was stationed. Between them were 2 watchtowers providing continuous surveillance of the area. A system of signal fires allowed messages about attacks to be transmitted from one end of the wall to the other in a matter of minutes. It was not a passive barrier, but an active line of defense, saturated with troops. The wall was not only a military border, but also a customs barrier controlling trade and tribal migration. The gates in the wall served as checkpoints where duties were levied and goods were inspected. The Romans monetized their security by forcing barbarians to pay for the right to trade with the empire. The wall was an economic tool as well as a military one. Order brought income. Behind the wall on the Roman side, a military road was built, allowing reserves to be quickly transferred to the site of a breach. Troops could maneuver along the front at high speed, responding to any threat. The depth of the defense was ensured by a network of large camps in the rear, where the main forces of the legions were stationed. The rampart was only the first line of a complex defense system. Construction took only a few years, which is an incredible achievement for such a large-scale project. The legionnaires worked under constant attack from the Picts, rain, and wind, but the schedule was not disrupted. Organization in iron will allow the project to be completed in record time. The Romans proved that they could build a border wherever they wanted. Hadrian's Wall became the physical embodiment of the border between civilization and barbarism, between order and chaos. For the soldiers on the wall, it was the edge of the world, beyond which lay the unknown. The psychological significance of this barrier was enormous for both sides. Rome said, "This far and no further." Even today, the remains of this wall stretch across the English countryside, reminding us of its former glory. The stones laid by the hands of legionnaires still lie in their places, resisting the passage of time. It is a monument to perseverance and discipline, capable of changing the geography of an entire island. The wall has become a permanent part of the landscape. Maintaining the wall required constant effort, and the Romans did not shy away from repairing and reinforcing it for centuries. It was a never-ending task, a daily feat of maintaining order at the border. As soon as the empire weakened and disappeared, the wall ceased to function, proving that the main fortress is people, not stones. One of the most striking examples of Roman speed was the construction of a bridge across the Rhine by Julius Caesar's troops. He needed to ferry his army to the Germanic shore to punish the barbarians, but he had no fleet. Caesar decided to build a bridge across the wide, turbulent, and deep river, something no one had ever done in this area before. The engineers accepted the challenge and got to work immediately. The deadline was unthinkable, only 10 days. The bridge's design was ingeniously simple and reliable. Slanted piles were driven into the riverbed at an angle against the current. This allowed the force of the flow itself to be used to compact the structure. The stronger the water pressed, the tighter the piles were compressed. Special pile-driving machines mounted on rafts drove huge oak logs into the riverbed day and night. The sound of the pile drivers became the sound of impending Roman retribution for the Germanic tribes. The wood for the bridge was cut in the nearest groves, processed on the spot, and delivered to the installation site. The conveyor belt worked continuously. While some drove in the piles, others laid the decking, and still others prepared the railings. The coordination of thousands of people resembled the work of a clock mechanism. There was no fuss, only the methodical work of professionals. To protect the bridge from floating logs and boats that enemies could send downstream, special fenders were installed upstream. These barriers broke everything that the river carried, protecting the bridge supports from impact. The engineers anticipated all possible threats, securing their creation. Foresight was part of the plan. 10 days later, the Roman army marched across the bridge, shocking the Germans. The barbarians, who considered the Rhine an insurmountable defense, saw that there were no barriers for the Romans. The psychological effect of this engineering marvel was stronger than that of a one battle. The enemies realized that they were fighting a force capable of taming the elements. Caesar spent only 18 days on the other side, after which he returned and ordered the bridge to be dismantled. It was a demonstration of absolute confidence and power. We can come when we want and leave when we want. The bridge fulfilled its purpose, becoming an instrument of intimidation and logistics. Engineering became an extension of politics. Another great bridge across the Danube, built by the architect Apollodorus of Damascus during the reign of Emperor Trajan, was even more grandiose. It stood on stone supports 45 meters high and had wooden arches with a span of more than 50 meters. This structure remained unsurpassed in length for more than 1,000 years. The Romans were not afraid of scale. They created it. Caisson technology allowed supports to be built on dry ground by pumping water out of fenced-off sections of the river. This required enormous labor and courage, but guaranteed the reliability of the foundation. Engineers descended to the bottom of great rivers to set foot on them. Water receded before the will of man. Bridges were key points in the road network, connecting the shores of the empire into a single whole. The destruction of a bridge was a disaster, so they were guarded like the apple of the eye. Everyone, from the emperor to the last soldier, understood the strategic importance of these crossings. A bridge is the life of trade and the death of enemies. Roman bridge building laid the foundation for all subsequent generations of engineers. The principles of load distribution, support protection, and working with currents are still used today. The bridges of Caesar and Trajan have disappeared, but the knowledge gained from their construction remains in history textbooks. The construction of gigantic structures required the movement of unimaginable amounts of materials. The Romans created a logistics system that allowed marble from Africa, wood from Lebanon, and metal from Spain to be delivered to any construction site. Maritime transport was the backbone of this system, turning the Mediterranean Sea into a Roman lake. Special heavy-lift cargo ships carried obelisks and columns weighing hundreds of tons. River transport was used to deliver goods deep into the continent, where rivers became natural roads. Barges carrying grain, bricks and stone flowed continuously up the Tiber, Rhine, and Danube rivers. The port infrastructure, with its cranes, warehouses, and docks, worked like clockwork, ensuring rapid unloading and loading. Stopping traffic meant hunger or a halt to construction, which could not be allowed to happen. On land, heavy carts drawn by oxen were used, for which those very ideal roads were built. Standardization of axles and track gauge allowed carts to easily pass along the stone tracks carved into the pavements of cities. The system was unified so that any transport could pass anywhere. This increased the efficiency of transportation many times over. The organization of supplies for the army and construction projects was a bureaucratic marvel of antiquity. Every nail, every sack of grain, and every amphora of wine was accounted for and recorded by scribes. Quartermasters knew where and how many resources were available at any given moment. Corruption existed, of course, but it could not stop the supply machine, which operated with enormous reserves. Warehouse complexes, such as those in Ostia or Rome, were impressive in their size and sophistication. Grain stores, horea, had raised floors for ventilation and protection from moisture and rodents. Food and material reserves made it possible to survive crop failures or sieges. Strategic reserves were the foundation of stability. The Romans also applied the principle of division of labor to transportation. Some quarried stone, others transported it to the port, and still others loaded it onto ships. Specialization increased speed and professionalism at every stage of the supply chain. No one did unnecessary work. Everyone was a link in the chain. Moving huge monoliths, such as the columns of the Pantheon, required special engineering solutions and roads. Sometimes a road had to be built specifically for the transport of a single stone. Costs were irrelevant if the goal was the greatness of the empire. Logistics was subordinate to the ambitions of the emperors. The reuse of materials was also part of the system. Old buildings were dismantled to build new ones. Marble was burned into lime, and columns were moved to new temples. The Romans were pragmatists and did not let anything go to waste. A closed-loop economy in action, supplying water and food to thousands of workers at remote construction sites was a separate and complex task. Field kitchens, water delivery, sanitary conditions, all of this was organized in advance. A hungry worker is a bad builder, and the Romans understood this perfectly well. Caring for the workforce was a matter of efficiency. Without this invisible web of routes and warehouses, no Colosseum would have been built. Logistics was the foundation on which the walls of all Roman megastructures stood. They conquered distance before they conquered their enemies. Ultimately, behind all these machines, concrete and roads were people. The Roman engineer, Prefectus Fabrum, was the elite of society, a man who combined the knowledge of a mathematician, the experience of a builder, and the authority of an officer. These men were personally responsible for their projects, often risking their lives. Their names were carved on stones next to the names of emperors. Pride in their work was a powerful motivator. Ordinary legionaries who built the empire with their own hands received decent pay and privileges for this. After serving, veterans received land and money, becoming respected citizens. Construction was a path to social mobility, an opportunity to secure a future for their children. They did not build for some abstract uncle, but for their state, of which they were a part. Hard work was considered a virtue in Rome, not a punishment, unless we are talking about slaves in the mines. Legionnaires were as proud of their calluses as they were of their scars. The cult of work and discipline permeated the whole of society. Idleness was despised, creativity was praised. This created an atmosphere in which impossible projects became reality. Engineering knowledge was not a secret of the priests. It was published in books such as the works of Vitruvius. Education was available to those who wanted to learn. The apprenticeship system allowed experience to be passed on from master to apprentice. The intellectual resources of the empire were enormous. Slave labor certainly played a role, especially in the most difficult jobs, but skilled tasks were performed by free people. Architects, foremen, and masons were professionals who received salaries. The myth that everything was built by slaves under the whip is false. Complex structures required intelligence and willpower, not just fear. The Romans possessed a unique winner's mentality. They did not recognize impossible tasks. If a mountain stood in the way of a road, they tore down the mountain. If a lake stood in the way of a city, they drained the lake. This boldness of thought was the main driver of progress. They believed that the world belonged to them, and they reshaped it to suit themselves. The corporate spirit of the legion created a sense of brotherhood, where everyone supported each other. On a construction site, as in battle, it was impossible to let a comrade down. Mutual assistance sped up the work and made it safer. Collectivism was the strength of Rome. Respect for the law and contracts ensured stable relations between the customer and the contractor. Construction contracts were clearly regulated, and deadlines and estimates were adhered to. The legal system protected the interests of construction. Order in the documents meant order on the construction site. Roman builders left a message for posterity not with words but with deeds. Every surviving aqueduct is an ode to human perseverance. They understood that life is short, but art, including engineering, is eternal. They built monuments to themselves during their lifetime. We look at their ruins with awe because we see in them the imprint of titanic efforts and great minds. Roman engineers proved that man is capable of anything if he is organized, trained, and motivated. This is a lesson that we have yet to relearn. We have examined in detail how the Roman military machine became the greatest builder in history. Standardization, discipline, simple but effective mechanisms, and ingenious logistics allowed them to surpass their time. They didn't look for easy ways, they created direct ways. Their concrete is stronger than ours, their roads lie beneath our feet, and their management principles still work in the world's most successful companies. The Roman Empire fell, but its engineering foundation proved indestructible. Which Roman technology do you think would be most useful to us today? Their eternal concrete or their iron discipline on construction sites? Suggest topics about antiquity that you would like to see covered in future videos in the comments. And be sure to subscribe to the channel so you don't miss out on new investigations into the mysteries of the past.